Our brains are intricate networks of communication. This communication relies on specialized chemicals called neurotransmitters. These messengers relay signals between nerve cells. One of the most important neurotransmitters is dopamine. Dopamine plays a crucial role in brain functions. These include movement, motivation, pleasure, and learning. Think of dopamine as the brain's reward system. It's released when we do something pleasurable. This release creates satisfaction and reinforces behavior. Dopamine's influence extends beyond pleasure-seeking. It's essential for regulating mood, attention, and movement. Understanding dopamine is key to understanding our brains. Dopamine's influence on our brain is multifaceted. It acts like a master conductor, orchestrating a symphony of functions. One of dopamine's primary roles is in reward and motivation. When we engage in activities that are pleasurable or rewarding, our brains release dopamine. This release creates a feeling of satisfaction and encourages us to repeat those behaviors. Dopamine also plays a crucial role in motivation, providing the drive and focus we need to pursue goals. Learning and memory are also heavily influenced by dopamine. When we learn something new, the release of dopamine helps to solidify the memory. This process is essential for our ability to learn and adapt to new information. Beyond these cognitive functions, dopamine also plays a vital role in movement control. It helps to regulate the smooth, coordinated movements of our muscles. This is evident in the devastating effects of Parkinson's disease, a condition characterized by dopamine deficiency and marked by tremors and difficulty with movement. Dopamine exerts its effects through a complex network of pathways in the brain. These pathways are like highways, allowing dopamine to travel to different regions and influence various functions. One of the key dopamine pathways is the mesolimbic pathway. This pathway is often referred to as the brain's reward pathway, as it plays a central role in pleasure, motivation, and addiction. Another important pathway is the mesocortical pathway, which connects the emotional and thinking centers of the brain. The mesocortical pathway is involved in decision-making, planning, and working memory. The nigrostriatal pathway is another critical dopamine pathway. It originates in a region called the substantia nigra and projects to areas involved in movement control. Finally, the tuberoin-fundibular pathway regulates the release of hormones, such as prolactin, which is involved in lactation. These four dopamine pathways work together in a delicate balance to ensure the proper functioning of our brains and bodies. Disruptions in any of these pathways can have significant consequences for our health and well-being. When the delicate balance of dopamine in the brain is disrupted, it can lead to a range of neurological and psychiatric disorders. Parkinson's disease, a neurodegenerative disorder, is characterized by the loss of dopamine-producing cells in the substantia nigra. This loss of dopamine disrupts the nigrostriatal pathway, leading to tremors, stiffness, and difficulty with movement. Schizophrenia, a complex mental disorder, is also linked to dopamine imbalances. While the exact mechanisms are not fully understood, it is believed that an overactivity of dopamine in certain brain regions may contribute to the hallucinations and delusions experienced by individuals with schizophrenia. Dopamine also plays a role in mood disorders such as depression. Low levels of dopamine are associated with feelings of sadness, apathy, and loss of pleasure. Attention deficit/hyperactivity disorder, ADHD, another common neurodevelopmental disorder, is characterized by inattention, hyperactivity, and impulsivity. Imbalances in dopamine signaling are thought to contribute to these symptoms. Parkinson's disease is a progressive neurodegenerative disorder that primarily affects movement. It's characterized by a loss of dopamine-producing cells in the substantia nigra, a region of the brain that plays a crucial role in motor control. As dopamine levels decline, the delicate balance of neurotransmitters in the brain is disrupted. This disruption leads to the hallmark symptoms of Parkinson's disease, including tremors, rigidity, bradykinesia, and postural instability. Tremors are often the first noticeable symptom of Parkinson's disease. They typically begin in the hands, but can also affect the arms, legs, jaw, and face. Rigidity is characterized by stiffness and resistance to movement. Bradykinesia refers to the slowness and difficulty initiating and executing movements. Simple tasks such as buttoning a shirt or brushing teeth can become challenging. Postural instability Another common symptom makes it difficult to maintain balance, leading to frequent falls. Schizophrenia is a complex and chronic mental disorder that affects a person's ability to think, feel, and behave clearly. While the exact causes of schizophrenia are still unknown, research suggests that an imbalance in dopamine signaling plays a significant role. Unlike Parkinson's disease, which involves a deficiency of dopamine, schizophrenia is thought to be associated with an overactivity of dopamine in certain brain regions, particularly the mesolimbic pathway. This pathway is involved in reward, motivation, and emotions. An excess of dopamine in the mesolimbic pathway is believed to contribute to the positive symptoms of schizophrenia, such as hallucinations, delusions, and disorganized thinking. Hallucinations are sensory experiences that are not real, such as hearing voices or seeing things that are not there. Delusions are false beliefs that are not based on reality, such as believing that one is being followed or conspired against. Disorganized thinking manifests as difficulty following conversations, jumping between topics, and making illogical connections. Dopamine's role in addiction. Addiction is a complex brain disease characterized by compulsive drug seeking and use. Dopamine plays a central role in addiction. Addictive substances hijack the brain's reward pathway, flooding it with dopamine. This surge creates intense euphoria, reinforcing drug-taking behavior. Repeated use changes the brain's reward system. The brain becomes less sensitive to dopamine, requiring higher doses. This is known as tolerance. Withdrawal symptoms occur when drug use stops. The brain attempts to readjust to the absence of the drug. Dopamine's role in addiction highlights the interplay between brain chemistry and behavior. Understanding these interactions is crucial for developing effective treatment strategies. Regulating dopamine, a balancing act. Maintaining a healthy balance of dopamine in the brain is essential for overall well-being. Our bodies have intricate mechanisms for regulating dopamine levels. One of the key players in this regulation is an enzyme called tyrosine hydroxylase. Tyrosine hydroxylase is involved in the synthesis of dopamine. It converts the amino acid tyrosine into L-dopa, a precursor to dopamine. Another important enzyme is dopamine beta hydroxylase, which converts dopamine into norepinephrine, another neurotransmitter. Medications can also influence dopamine levels. For example, levodopa, a medication used to treat Parkinson's disease, is converted into dopamine in the brain, helping to replenish depleted levels. Antipsychotic medications, on the other hand, block dopamine receptors, reducing the effects of excess dopamine. These medications are commonly used to treat schizophrenia and other psychotic disorders. Understanding how medications interact with dopamine is crucial for optimizing treatment outcomes and minimizing side effects. The importance of dopamine in health. Dopamine's influence extends far beyond the realm of disease. It plays a vital role in many aspects of our daily lives, from our ability to experience pleasure and motivation to our capacity for learning and memory. Maintaining a healthy dopamine balance is essential for both mental and physical well-being. Several lifestyle factors can influence dopamine levels. Exercise, for example, has been shown to increase dopamine production, leading to improved mood and cognitive function. A balanced diet, rich in tyrosine-rich foods such as almonds, avocados, and bananas, can also support dopamine synthesis. Stress, on the other hand, can deplete dopamine levels, contributing to feelings of anxiety and depression. Engaging in stress-reducing activities such as yoga, meditation, or spending time in nature can help to mitigate the negative effects of stress on dopamine levels. By making healthy lifestyle choices, we can support our brain's delicate dopamine balance and promote overall well-being. Dopamine's powerful influence. Dopamine, the brain's master messenger, plays a profound role in shaping our thoughts, emotions, and behaviors. From the exhilaration of achieving a goal to the devastating effects of Parkinson's disease, dopamine's influence is both wide-ranging and profound. Understanding the complexities of dopamine signaling is crucial for unlocking the mysteries of the brain and developing effective treatments for a range of neurological and psychiatric disorders. As we continue to unravel the secrets of this remarkable neurotransmitter, we gain a deeper appreciation for the intricate workings of our brains and the delicate balance that underpins our health and well-being. By fostering a greater understanding of dopamine, We empower ourselves to make informed decisions about our health and well-being, paving the way for a brighter and healthier future. This has been another Mental Health Minute or 10. Remember to like and subscribe to keep up to date.